Hey everybody, this video lesson is going to take us through the techniques of doing a titration. First thing we're going to talk about is what is a titration? It's the gradually adding of one solution to another to reach the equivalence point. Since this is the acid-base chapter, we're going to talk about acid-base titrations. Now it's easy enough to take a beaker of acid and pour it into a beaker of base and mix them together, but a titration is done so very, very carefully. And the key is to add just enough acid to the base, or base to the acid, so that you completely neutralize the acid or the base, which means that the pH is 7, or all of the original base is gone and has been reacted with the acid. We'll talk about the chemical reaction involved in a neutralization in a later video lesson. But the key point that I want to make before we move on is that at the equivalence point, the pH is 7. Now you might be asking yourself, how in the world do we know when the pH is 7? Because an acid is a clear solution and so is a base. And so you mix an acid base together, all you have is a more clear solution. And the next slide is going to take us through some techniques to determine when you've reached pH 7. So there are three different predominantly used techniques to determine when pH is at 7. The first is called pH paper, which is a chemically treated paper that changes color depending on the pH of the solution when you dip it in. That is the cheapest way to determine the equivalence point, but is not the most accurate or the most precise. Now the one on the bottom is a digital sensor, which is a little device that plugs into a computer and measures the pH consistently. So it constantly monitors the pH of the solution. Now as you'd probably imagine, it's digital, so it's very expensive. We have some of these, but they're not the most useful because we only have enough to handle a few titrations. So what we'd use instead is the one in the middle. It's the medium cost and the medium effectiveness. It's called the acid-base indicator or color-changing dye. Now what these dyes do, and there are many different kinds of indicators that change color depending on the pH, is that they are one color at a particular pH, and then as soon as the pH goes above or below a certain pH threshold, they change color. The one that we use most often is called phenolphthalein, and it's clear in an acid and converts to pink in a base. And so when you're doing a titration, you'll start with a clear acid, and then as you add base, it'll turn pink a little bit, and disappear, and then eventually you drop in one drop of base and the whole solution turns completely pink. And at that point, you know that the pH in the beaker has changed from below 7 to above 7, or from above 7 to below 7, and that's when you know you can stop the titration, once you've reached the equivalence point. Now, let's talk about some of the things that you're going to be using in a titration. The first thing is called a burette. Burette is a graduated cylinder that actually counts from top down with a nozzle on the bottom. Graduated cylinders normally count from bottom up because you're measuring a certain number of volume, but in a burette, it counts from top down. And that's okay. You don't actually need to calculate total volume inside the burette, but rather you're going to calculate how much of the titrant, which we'll talk about in a second, how much of the liquid in the burette has gotten used up in the process of a titration. The burette is the substance that holds the titrant. Now what is the titrant? Well, it's a substance in the burette. How do you remember what the titrant is? It's the titrant's on top. The analate is down below. Now if the titrant is acid, then the analate is base. If the titrant is base, then the analate is acid. Finally, the stopcock is the part of the burette on the bottom that controls the flow. If you open it up partially, you can get little drips of liquid coming out, but if you open it up all the way, you can get a steady stream. It's important that you know how to control the flow so that you don't overshoot the equivalence point, because you don't really know, once you've overshot it, you don't know how far over you went. Remember, the point of a titration is one drop is going to be the difference between a clear solution and a pink solution. Now here's what a setup looks like. You've got the titrant inside the burette up on top. Down below you have an Erlenmeyer flask with the acid and indicator. Could be acid on top, base on the bottom, base on top, acid on the bottom. And this is the stopcock used for controlling the flow. So I'm going to go through the steps in doing a titration. And you'll be doing these same steps every time. The procedure is repeated every single time. The goal is, and we'll talk about the calculations involved later, but the goal is to do the titration first and then use the information from the titration to answer a question about the acid or the base afterwards. So these steps are the first phase and the calculations are the second. So here we go. First step is measure out the volume of the analate and put it into an Erlenmeyer flask. Remember, the Erlenmeyer flask is that cone-shaped piece of glassware that's underneath the burette, and it holds the analate. Next, you put 2 drops of indicator into the analate with the analate itself. And so a lot of students want to put more drops in because they think more is better. But indeed, 2 to 3 drops is all you need in order to get the solution to appropriately turn color from clear to pink or from pink to clear. Finally, you fill the burette with titrant and record the starting volume of the titrant to 0.01 milliliters. It's important that you measure to 0.01 milliliters because these burettes are accurate to the tenth of a milliliter, so you can estimate the last place value. Now, typically, I will have filled the burettes for you ahead of time, and so you simply just need to step up and record the starting volume of the titrant. So you'll see the burette, and it probably will be a concave surface, and you measure from the bottom of the meniscus. You just simply mark on this, and remember it counts from top down, you mark or write down how much volume or what the line is at. So for example, it might be 1.05 milliliters to start. So next up, you add the necessary amount of titrant until you've reached the equivalence point. The amount of titrant added changes depending on how much of the analate you use initially, the concentration of the analate, the concentration of the titrant. So all of these things play a factor. So that's why it's very vague. It just says add necessary amount. Once the indicator changes color, you stop the titration. So when you finish, you go back to the burette and you record the final volume. The final volume will be the volume that you end your titration with. And then what you do is you subtract these two numbers to figure out how much of the titrant was used. Now write down that amount of titrant used in a special spot because you're going to need it to do the calculations next. You're going to practice this time and time again, and you're going to become very familiar with these steps. Most common mistakes I see are people not putting in the indicator, and so they're titrating, and it stays clear, stays clear, stays clear, and I say, well, did you add your indicator? Typically they say yes, and then they go, oops, just kidding, and they forgot to add the indicator. The other thing is people don't use the technique properly of 1 drop at a time close to the equivalence point. And what happens is they put a stream of liquid in and it turns the entire solution pink, and they don't know if it was the first drop that did it or the last drop that did it or any of the drops in between. Remember, the goal is to be as precise as possible and stop titrating as soon as the analate goes from clear to the faintest pink. The next video lesson we'll talk about how to do your calculations. That takes care of this video lesson. Thanks for listening.